Okay, in this video, I'd like to look at some gate combinations. And I'd like to take the examples from the basic exercises. So if you're looking at the basic exercises and you want some guidance, then you might want to watch this video. So we begin with this combination. So the very first thing we need to do, and this is question 1A in the basic exercises, what this does is it combines two gates, lettered A and B, but B has this little apostrophe, so we'll have to remind ourselves what that means, and we've got a plus sign between them. So let's interpret this correctly. Choose a different colour. The things we need to interpret is what is this and what is this. What we can assume is that we have two inputs. We have an A and a B, because we have two gates. But what do we do in the combination? Well, first of all, let's take each letter one at a time. So we take this first of all. This little apostrophe means not. And what that means is that the input from B has to be negated or inverted. So let's just let that extend along a bit. Okay, so that's the first thing to notice with that. So that B value, it has a not. There's the B value, it comes in, there's the not, it goes on, right? Then, so we've covered that now, that's all been encoded in this. We now have this plus sign between the two, and the plus means, if you remember what we said, let's use a different colour, an OR gate. So actually, what we need to do here is both that and that need to go in to an OR gate. So let's get a yellow here and let's draw with a curve there, slightly pointy, that's the OR gate. And the output we'll call X. X equals the output. That's how you translate. That's a simple example. In the next slide, I'll pick the next example. So our next example is X equal A, B with a little apostrophe. And again, we want to interpret this correctly. Well, the first thing to notice is that this B has this not symbol on it. So the B will have to be inverted. And the two terms are multiplied, which means it's an AND gate. So let's take it each a piece at a time. So we have A, which is going to input. We have B, but B has a not. So we put that through a not and then carry on with that. And they both are multiplied, so there's an AND gate, which is the flat line, and it looks like that. And that describes the combination. Let's look at the next problem in the basic exercises. So next up we have 3, A, B, C. And the first thing to notice with these are that there are no apostrophes, no plus signs, they're all multiplied. If they're all multiplied, multiplication means an AND gate. So if we represent them, we have these three inputs, A, B, and C, and they're going in to an AND gate. Remember, it's flat with an extended semicircle, and that's the output. And that's the combination. Let's take the next example. The next example is X equals A plus B plus C. Okay, now what do we notice? These terms are all on their own. There are no apostrophes, no multiplications, okay? Now remember, it's a little bit like BODMAS. You do look at each combination and multiplication first, and then you do the addition after. So think, when you look at these combinations, of the mathematical rules of BODMAS, and they can give you a starting point of how to deal with this. So with this one, we just have A, B, and C with a plus sign between all of them. So let's draw it. We've got A, B, and C, three inputs, and they have plus signs, and the plus sign represents OR. So we drop in an OR, which is a little curve there, line there, with a slightly pointy curve there, and that's the output. And that's what it looks like. Nice and simple. Let's have a slightly more complicated version. In this version, our output is a combination of A of these three. Now the only difference between this one and the previous is the A has an inverter. So we take our A and we invert it. B and C are fine, they go straight through. And they're all plus signs, so it goes through to an OR gate, just as we did in the previous example. There's your combination. Let's jump a bit and find a slightly more complicated version now. I'll let you work through the other ones. Okay, I'm going to move to J in the exercises. In this one, we're interested in this combination, AB plus C. Now, I said earlier to use BODMAS. Now, if we use BODMAS, we use look at the multiplication and the separate terms. There are two multiplications. There's a multiplication here. So A and B are being multiplied mathematically, which means an AND gate. So we get our A, B, and they're both going into an AND gate. So it's flat, pointing outward. So that in blue covers, let me just write that out, that covers, let's change the colour of that, that's this bit here in blue. Now C has a plus sign. C is combined with whatever this outputs with a plus sign, and the plus sign means an OR. So let's use yellow. So we've got C coming in as well. So these two are combined in an OR, and it looks like that. And that's how you draw it. So there's your AB combination, and there's your OR C. So that combination outputs here, which is this bit here, and it goes into an OR gate, which is represented by the plus sign with C, and that's your output. Let's pick a slightly more complicated version, the very last one of this sequence to end this video. In this last one, we have our output is AB plus not C plus DE. So we can see we have 1, 2, 3, 4, 5 inputs. So let's take them a group at a time. Let's take the AB. AB multiplied suggests that they go into an AND gate, because that's the multiplication. So that's that bit there. Let's look at the next term. So we've got C, not C. So we take our C and we put it through an inverter, triangle, and that's that bit there. Finally, we've got a DE combination. So let's write DE, and they're multiplied, so it's another AND gate. Then finally, between each of these terms, I'll do it in red, we have a plus sign, which means OR. So we grab an OR, pop it here, that's the very last step, and so the input of that goes there, the input of that goes there, and the input of that goes there. And that's how we represent it.